Friends, let's quickly discuss the problem of forecasting um, while at the same time explaining the XIV VIX trade. The VIX, a bunch of people constructed a contract saying the VIX is overpriced, it misprices volatility, it is overforecast what's going to happen, the variation in the market, the contract is poorly designed. Let's make money off of that, and they were right, but they were destroyed and lost all this money. Why? Because they didn't realize that forecasting has nothing to do with P&L, nothing to do with real life. What matters is your payoff function. So these people were right. If you invested, say, $25, you would have made some money. It would hit, I think, a high of $146 over time. And in one or a couple of days, they lost everything. It's now at $5, and it probably is generous, should be lower. So what did they do that was wrong? What they did is not understand that being right on a random variable x doesn't mean making money off of it. Your payoff function f of x needs to be aligned with what you're forecasting. And in fact, the payoff function f of x is never x, and f of x can be very complicated. In real life, most people who think you have to focus on x are academics or other idiots. F of x is what you focus on when you make a decision. It's much easier to understand your function of a random variable than the variable itself. That's what I said throughout Antifragile. Very few people are getting it. Academics cannot get the idea that you don't have to be right about the world. You have to make decisions that are convex, in other words, decisions that make sense. And in fact, you don't have to be, and in fact, this also explained why paranoia is entirely justified if your f of x is concave. So you overpricing and underpricing probabilities is not what matters. What matters is your payoff function. So let's see what happened here. Let's take your payoff function. Remember, you have a payoff function that's a polynomial. Pretty much everything in life is some nonlinear payoff function that can be expressed through splined polynomials. In other words, you add these payoff functions, and of course you can do it more sophisticated way, but that's pretty much what it is. And this is a way for us to understand first order nonlinearity. So you plotted 1 minus x squared. You see what happens here. And I build a function of a vector. Cap x is a vector, is the mean 1 minus x squared. So what does it do here? You say you put a vector like x0, 1, 1, 1, 1, 1. The mean of x0 is 1, and f of x0 would be 0. Okay, that's a function. So, and let's do a thought experiment, another thought experiment. X itself, say, is 1, 1, 0, 1, 1, 1. The mean of x is 0.71. And of course, they're going to make money because they think it's going to be lower than 1. 1 is the price at which you're forecasting. In other words, or what you're starting off with is going to be lower than 1 or higher than 1. And you have a concave payoff function. So you think the average is going to be lower than 1, your average is lower than 1, you make 0.28 because it's distributed in a certain way that sort of works. But now if I take the same average with x2, 0, 0, 0, 0, 0, 0, and then 5, in other words, all the variation came from one observation, 1, 2, 3, 4, 5, 6, seventh observation. It summarizes everything, all the properties. Then let's look here. Mean of x2 is n, but f of x2 is negative. Aha, although you're right on x, you're wrong in your payoff function. You're going to be harmed big time. Like I often say, the idea, I've never seen a rich forecaster. Good forecasters are always poor because they won't get into that. The average forecast is not what matters. What matters is not to be harmed by these concavities. Now, let's take an extreme case. X3 is, I have 999 zeros and then one observation at, say, 1000. Okay, that's X3. and the mean of X3 is 1. Visibly, you're short at 1, and you lose 999. Even if that was 300, okay, you have a lot of zeros, and the last observation is 300, okay, the mean is going to be 0.3, and you still lose money, okay. The variable you're forecasting came 75%, 70% below what you're forecasting in the right direction, and you still got hammered. So this is to explain the fallacy of forecasting in a very short note. Thank you for listening to me, and have an excellent weekend. Bye.